In this video, the motivation is to derive the relation for variation of mass with velocity. So the target of this video is basically to achieve m equals m naught by under root of 1 minus v square by c square. This is our target. And in doing so, what we assume is that we take the similar situation like this. We have two frames of references, and this is frame of reference S, this is frame of reference S dash, and it has an origin O, it has an origin O dash, and we have what we assume here that we have two inertial frames S dash and S. And this S dash is moving with the velocity. This S dash, the frame of reference, is moving with the velocity v in the positive direction of x-axis. And let us assume that there are two balls, say ball A and ball B. There is another ball B, and this the mass of these two balls is same. They have equal masses, and they are traveling in opposite direction. All right. With velocities u dash, and this must have velocity minus u dash. Okay. Now these two balls collide in S dash. They collide in S dash, and after collision, they stick to each other. They coalesce into one body, and they coalesce into a single mass 2m after the collision. So you have a situation before the collision, and you have a situation after the collision. And the total mass of the system becomes 2m. And these two balls instantaneously come to rest, obeying the law of conservation of momentum. All right. Now let's try to move on from here and see this how we would like to treat this collision experiment, and how this experiment is performed in S dash appears in the frame S. Now let us suppose the mass of the body A that we have, it appears to be m1, okay, and that of the body B appears to be m2, and their velocities they appear to be u1 and u2. So what we are trying to do here is we are seeing this collision experiment performed in S dash. It's performed in S dash, and how it appears in the frame S. So the mass of the first object is taken as m1 with respect to S, and mass of another object is taken as m2 with respect to S. So that should be clear. Now after the collision, the balls have come to rest in S dash. And what it means basically is that only velocity the two balls possess after the collision is the velocity of the frame, because the frame is moving with the velocity v. So they are instantaneously coming to rest, the two masses, when they stick together, when they coalesce together. So what is happening is that these balls, the only motion that we have here is that the S dash is moving. So the only velocity that this 2m possess after the collision is the velocity of this frame S dash, which is equal to v. Okay, and thus two balls appear to move with the velocity v to the observer in S. So what's going to happen? They have come to rest, but for S, they appear to be moving with velocity v. Now let's use the transformation equations that we have already derived for velocities. So here, what will be u1? u1 will be u dash plus v by 1 plus v by c square u dash. Okay, and what will be u2? Okay, u2 is going to be minus u dash, because the motion is opposite, minus u dash plus v by 1 minus v by c square u dash. This is going to be the situation. All right. So here we can proceed with this. So u2 will come out to be v minus u dash by 1 minus v by c square u dash. So we have u1 given by this equation, and we have u2 given by this equation. Now, what is happening to the linear momentum in this case? As linear momentum is conserved in all inertial frames of references. Okay, so the total momentum of the balls before the collision must be equal to the total momentum of the balls after the collision. So let us write down this conservation of momentum for these two balls. So when we write down the conservation here, so what we have, we will have m1u1 plus m2u2. Okay, that must be equal to m1 plus m2 times v. Now, v we understand is the velocity with which the frame S dash is moving, but 2m is momentarily at rest. All right, so for u1 and u2 we can use here. We have u1 and we have u2. So for u1, so what I'll get is m1 times u dash plus v by 1 plus v by c square u dash, and then close plus for m2, it's m2 times u2. Okay, how much is u2? That is v minus u dash by 1 minus v by c square u dash. And this is going to be equal to, this is going to be equal to m1 plus m2 times v. That's fine. Nothing wrong with that. Okay, so that should be the case. Now, what we will do is, this is m1 times u dash plus v by 1 plus v by c square u dash. This m1v we will transfer to the left, so this is m1v is equal to, so in the right hand side what we have m2v, and we will transfer this thing on the other side, so this will be minus m2 times v minus u dash by 1 minus v by c square u dash. Okay, that should be the case. Fine. So here we will have common m1. So what will be inside? It will be u dash plus v, then simply minus v, then minus v square by c square u dash, okay, divide by 1 plus v by c square u dash. Okay, this from this side what we will have is, here the LCM will be 1 minus v by c square u dash, and then you're going to have this term to be multiplied with this, and then minus this. The same thing is here, it's divide by 1. We have the LCM, so what we have done, we have multiplied this with this, and multiplied this with this, and taken m1 common. So the same thing we are going to do here. So we will have m2 outside, so inside we'll have v minus v square by c square u dash minus v and plus u dash. All right, so this should be the case. We can see here this plus v and minus v is going to cancel here, and in the similar way this plus v and minus v is going to cancel here. So what we are going to be left with is, m1, m1 times u dash minus v square by c square u dash, okay, divide by 1 plus v by c square u dash is equal to m2 times, that is u dash, okay, minus v square by c square u dash, divide by 1 minus v by c square u dash. This should be the outcome. Now what we can do is, I think we can see this is u dash minus v square by c square u dash. This is u dash minus v square by c square u dash. We can see it from here, okay? From here we can see it, it's coming exactly u dash minus v square by c square u dash. So u dash minus v square by c square u dash. So what's going to happen? This term is going to cancel with this term. So what I'll be left with is this m1. Okay, I'll keep it there. I'll get down this m2. So what I'll have 1 plus v by c square u dash divide by 1 minus v by c square u dash. So this is the ratio of the two masses that's coming in terms of these velocities, right? Now, if I go back to this equation, I will call this equation A for the time being. So what I have u1, so I have u1 equal to u dash plus v by 1 plus v by c square u dash. Okay, so what would I like to do here is I would like to take it square. So this will be square of this is equal to square of this. Now, what I will do in this case, so I will call this, say, B for the time being, okay? And in this equation, I will be dividing both sides by c square. So if I do that, what am I going to get? I'm going to get u1 square by c square is u dash plus v by 1 plus v by c square u dash, okay? This whole thing is divided by what we call as u1 square. Fine. And I can write down 1 minus u1 square by c square is equal to 1 minus 1 by c square times u dash plus v by 1 plus v by c square u dash. And nothing should be wrong with that. So if I proceed from here and keeping left hand side as it's for the time being, what am I going to get here is I will have a situation like this. What I will have is I will have this is 1 minus this whole term, right? So here I will have the what I call it as let me go with this, make it this way. So this is c square times u dash plus v by 1 plus v by c square, then u dash, okay? That's it. So we would like to multiply this with this 1. So what I'll get c square times 1 plus v by c square u dash, and 1 times this will give me, it will give me minus u dash and minus v. That should be the case, right? So now what I'll have is 1 minus u1 square by c square is, okay, this is 1 minus u dash plus v whole square. I can write divide by c square, and I can write divide by 1 plus v by c square u dash. Okay, this can be the situation that can be generated here. Very simple. Okay, so the c square will simply go here. And now I would like to have the LCM, that will be 1 plus v by c square u dash. Now this term will be multiplied with 1, and we'll get 1 plus v by c square u dash, okay, then minus what we will have is 1 times this, so this will be u dash plus v divide by c square whole square, all right? That should be the case. And we can write down another step here, that's 1 plus v by c square u dash is okay. And then here what I have is a square, so this is plus u dash square by c square plus b square, that is plus v square by c square. Then what I have is, okay, what I had to keep in mind is minus is outside, so this will automatically become minus, this will automatically become minus, and plus 2ab, that will become minus 2 u dash v by c square. That seems to be the story over here. This is whole divided by 1 plus v by c square u dash. And in the left hand side, what we have is 1 minus u1 square by c square. It's crazy. Okay, so to proceed from here, what we are going to achieve is, we can see that do we have something that can be thought as, this is u1 dash square. So if I rearrange it, okay, so this is my left hand side is 1 minus u1 square by c square. So this 1 minus u dash square by c square, I will write 1 minus u dash square by c square. Okay, I would like to put it in the brackets. Then what is left? So these two terms are gone, and what is left is v by c square. So this is plus v by c square u dash. Okay, then minus v square by c square, minus v square by c square, then minus 2u dash v. Okay, then minus 2u dash v by c square, and this whole thing is divided by 1 plus v by c square u dash. Okay, that's what we have right now. And what can we proceed with? We can proceed with here. So this is 1 minus u dash square by c square times, there's no times right now. If I get v square by c square, I think I have missed something here. And what have I missed? Yes, okay. Oh shit. This is whole square. This is whole square. So this thing is whole square here. Oh no. I have 1 plus v square by c to the power of 4 should be this u dash. Then plus, here I have to add a term, plus twice v by c square u dash. Because this is whole square, I have missed it. This is whole square here. I have done it wrong. So this thing is going to cancel over here. So what I have, plus 2v by c square. Okay, 2v by c square is coming out to be a square plus b square and plus 2ab. That's 2v u dash by c square. And we can see that this 2v u dash by c square, this is plus and this is minus. These two terms are going to cancel. I have done it wrong. I'll have to change the page. Okay, so what will be the thing that I'm getting here is 1 minus u1 square by c square. Okay, so here I'll be left with 1 minus, this is equal to 1 minus it is u dash square by c square. Okay, and what we are left with? We are left with these two terms. We are left with this term and this term. And in these two terms, I think v square by c square can be common. So I can write minus v square by c square times what will remain inside. This is v square by c square, and since I'm getting it out as minus, so it will be 1 minus u dash by c square, because here we have c to the power of 4. So it will be v square by c square is out, okay, that two minus, and we'll get the same terms if we remultiply these terms. So what is divided here, this whole thing is divided by 1 plus v by c square u dash. All right, whole square, it has to be whole square. I have to write this as whole square. Okay, so then proceeding in the same fashion where we are right now is, we can see here that we have 1 minus u dash square by c square, 1 minus u dash square by c square, Out of these two, what I have is they are common. So what I can write here is 1 minus u dash square by c square times 1 minus v square by c square. So what will be in the denominator? It will be 1 plus v by c square u dash square whole square. And what's in the left hand side is 1 minus u1 square by c square. So this is the equation right now that we have. And if I take root on both sides, and what's going to happen here is okay, that's fine. Yes, u dash square. It has to be u dash square here, okay? Because this is a square. That's 1. B square is u dash square. Okay, so u dash square is incorporated here, and if we put on roots on both sides, okay. So let me put a root, like this, and I can put a root like this, and in this case, what I'll have this square and root can we have square inside, okay, and what we have here is now the final equation in terms of the root that we have is I have taken roots on both the sides, and if I do, okay, what's going on here? What I have here is square is fine here. So if I have roots all the way, what am I going to get is if I do the squaring, and I'll see what's going to happen. I'm going to get the same thing. So what I have is I have u1 1 minus u1 square by c square. That's correct. Okay, 1 minus u1 square by c square, and so this square and root will cancel, and what we will be left with, it's better to take another page, and what we'll be left with is 1 plus v by c square u dash square. Okay, this will be equal to, and we'll get this down to the denominator, so this whole thing will come under root. So you will have 1 minus u dash square by c square times 1 minus v square by c square. Okay, divide by, okay, this root term will go, this is 1 minus u1 square by c square, and this is the equation that we have achieved, okay. And by changing, I should write it here, by changing u dash by minus u dash in the left hand side, and changing u1 on the right hand side to u2. Okay, so what we will get another equation. I will call this equation as equation X, and here I'll get 1 minus 1 minus u dash v. I think okay, 1 minus u dash v divide by c square. This is equal to under root of 1 minus, this will remain same because we have square of it, u dash square by c square times 1 minus v square by c square divide by 1 minus, instead of u1 I'm going to write u2, so this is 1 minus u2 square by c square. Now this whole thing is in the root, okay. And so if we go back, and if we see that in this equation, where is that? I have here, I have square and root that was cancelled once I took the root. So here I have only u dash. So by mistake I have written here square of it. Now if we go back to the original equations that we have got, we have this and we have this. These two ratios are simply m1 by m2. These two ratios are simply as m1 by m2. And we can see here that m1 by m2 is the plus term divided by the minus term. So instead of these two, if I divide the two equations, instead of the ratio of these two, I'm going to write directly as m1 by m2. So x, that was x, this is y. Now I'm dividing x and y. So dividing x and y will give me m1 by m2. Okay, so we can see here one thing is quite clear, that these denominators will cancel, these numerators will cancel, and what we'll be left with is 1 minus u1 square by c square whole raised power 1 by 2 divided by 1 minus, so this should be u2. Okay, this should be u2, and this is u1 square by c square whole raised power 1 by 2. Okay, so this is the final result, and from this result we will go with more approximations with some assumptions, and we will achieve the equation for relativistic mass. And so what's going to happen here is, now if I assume if I assume that the body which is B, and if I assume the body B, which has mass m2, is at rest before the collision, So if that is the case, then u2 kind of thing is going to get out of it. Okay, so assuming that m2 is at rest before the collision. Okay, so I have A and I have B. I'm assuming that B is at rest before the collision. If I assume that, then this whole term will boil down to 1, and what I'll get is m1 by m2 is 1 by under root of 1 minus u1 square by c square. This should be the case. So I can take this m2 up, and what will I have? I will have m1. So m1 is going to be m2 by under root of 1 minus u1 square divided by c square. Okay, that's the case. Now what I have, mass 2, m2. Now this m2 is generally written as m0. It's written as the rest mass, and we call this thing as rest mass of the body. Okay, so if that's the case, what will be m1 then? So m1 is going to be m0 by under root of 1 minus u1 square by c square. And if this m1 is taken as m and u1 is taken as v, what we'll get? So if I take this m1 is m, a body moving in a frame of reference, and having some velocity of that frame of reference, then this u1, its velocity is v. What am I going to get is m is equal to m0 by under root of 1 minus v square by c square. So this equation basically shows now how the mass of the body varies with the velocity of the body. Now for ordinary velocities where we have v very, very less than c, this equation will boil down to m is equal to m0. So here we can say that Newtonian mechanics perfectly prevails, and mass is an absolute physical quantity. And thus the mass of the body does not change at all if the velocity is very, very less than as compared to the velocity of light. Now, if for the sake of argument, take a small example at this point of time, that I have electron, the mass of electron is, rest mass of electron is 9 into 10 to the power of minus 31 kilograms. And I would like to calculate its traveling mass. I want to calculate its traveling mass. And this electron is moving with the speed that it has speed equal to, say, 0.8 c. And we can calculate the relativistic mass for this electron. That will be m naught by under root of 1 minus v square by c square. So for m naught, I have 9.1 into 10 to the power of minus 31 divided by 1 by divided by under root of 1 minus v square. So this is 8 8 it is 0.64. It's 64 by c square by c square, and c square is going to cancel. So this is 9.1 times 10 to the power of minus 31 divided by this is how much? This is nearly, it is 0 point, okay, this is, okay, this is 6, and this is 5. So nearly 0.6. So this is 0.6. Okay, so this will come out to be 15.1 times 10 to the power of minus 31 kilograms. So the relativistic mass, the mass of the electron, if it is moving with the speed 0.8 c, it's going to be 15.1 times 10 to the power of minus 31 kilograms.